Greetings! In this video we will discuss the GitOps approach in KubeRocketCI. This video is part of the updated KubeRocketCI 3.13 series that reflects the new UI, current terminology, and updated platform workflows. In the previous video we covered deployments and environments in detail. If you haven't watched it yet, it's worth checking out first, since we'll be building directly on those concepts here. We will get familiar with what GitOps is, its benefits, how it's implemented in KubeRocketCI, and we'll apply it to a real deployment. Let's start with the basics. The core idea of GitOps is to store and manage the desired state of an application in a Git repository as a single source of truth. Depending on the team and project, that repository might store infrastructure as code templates, application code, Helm chart configurations, and more. Applying the GitOps approach brings a bunch of benefits. In a GitOps repository, updates are applied via commits and pull requests. This means you can easily track what changed, by whom, and when. And if anything goes wrong, rolling back becomes a straightforward process. Additionally, GitOps helps improve security by narrowing the scope of access. Instead of giving users direct access to environments or clusters, you can manage permissions entirely through Git. To understand GitOps advantages better, let's look at a real-world use case. Imagine you have a deployment with several environments: dev, QA, and prod. Each one requires unique Helm chart parameters for the application, such as replica counts, external endpoints, resource requests, and so on. A developer defines those parameters right in the GitOps repository. The repository then fans those parameters out as separate values per file environment, each one feeding into the corresponding environment in the cluster with its own replica count, resource limits, and other parameters. One deploy pipeline serves all 3 environments. The GitOps repository is what makes each one different. If there is no GitOps approach, you would need to define different parameters each time you run a deploy pipeline, or make 3 different deploy pipelines with minimal changes. Now, let's see how GitOps works in KubeRocketCI. In KubeRocketCI, the GitOps repository acts as a shared codebase. Like any other codebase, it's listed in the project section, where you can open it and view its contents in Git. It's added as a system-type codebase, and the platform allows only one GitOps repository at a time. Just like other codebases, it has its own review and build pipelines. The difference is that the build pipeline doesn't build any artifact. Its job is the same as the review pipelines. Both use YAML int to validate YAML syntax and structure, so you can catch mistakes before they reach the GitOps repository. Unlike other codebases, though, a GitOps repository is added from the configuration section. There are 2 strategies for adding a GitOps repository: create and import, the same pair you've seen for other codebases. It's worth noting that KubeRocketCI itself is built and configured using the GitOps approach. Instead of creating pipelines with the Create Resource button right in the KubeRocketCI portal, you can manage your pipeline definitions in a Git repository, then import them into the platform as a codebase of the library type. This lets you fully version and control your pipeline configurations using Git. Another convenient option is our add-ons repository, which you can fork into your own account. There, you can set up configurations for most integrations supported by KubeRocketCI, making setup even faster and easier. This flexible approach lets you choose the best configuration workflow for your team. The GitOps repository plays a key role during application deployment to environments. Adding a GitOps repository is a prerequisite for creating a deployment. It allows you to redefine the application's Helm chart parameters per environment. To make an environment use the GitOps repository as a source of truth, you enable the values override option when you trigger a deploy. When it's enabled, the platform checks the GitOps repository, locates the corresponding file, and applies the parameters defined there to override the Helm chart values. One GitOps repo stores all the redefined parameters for every deployment and environment on the platform. To keep the repository contents organized, it strictly follows a specific file structure. First, create a directory with the same name as the deployment you want to redefine values for. Inside that directory, create another folder with the same name as the environment. And inside that folder, create a file named application-name-values.yaml. So the resulting pattern is deployment name / environment name / application name-values.yaml. Now that we understand what GitOps is and how to use it in KubeRocketCI, let's put theory into practice. Together, we will add a GitOps repository, configure a deployment, and override values for an environment. Navigate to the portal. In this demo, we will be using the orders processing application. Let's open the Deployments tab. Since no GitOps repository is configured yet, we are expected to see this message. Clicking the link takes us straight to the GitOps repository page in the configuration section under Deployment GitOps. Click Add GitOps repository. On the form that appears, select the Create strategy, choose the available Git server, specify the account name and repository name, and click Save. Okay, great. Now let's quickly create a deployment for the application. Navigate to Deployments and click Create Deployment. Select the orders processing application and its branch, and click Next. Give the deployment a name and description, and click Create. Now let's add a dev environment. Click Create Environment. Fill in the basic configuration: cluster, environment name, namespace, description, then move through pipeline configuration and quality gates with the defaults and click Create. Now let's deploy the application as usual, without any override yet. While the deploy pipeline is running, let's quickly look at the Helm chart parameters for this application in Git. They are defined in the values.yaml file of the deploy templates folder. According to the default configuration, it deploys only one replica. We are going to change this using GitOps. Okay, the application is deployed. Let's check the replica count in the Argo CD application resource. Indeed, there's only one replica. Now let's increase it using the GitOps repository. Get back to the portal and open the GitOps repository from the deployment. GitHub shows the file is not found message. That's expected, since we haven't created it yet. Open the Code tab. Now we need to create a pull request that adds the values.yaml file for the application. We will fast forward this process to save time. Okay, now we have a pull request with a file containing new values. The review pipeline has completed successfully. In the root folder, we created the orders processing deployment /dev/orders processing values.yaml file. In that file, we redefined the replica count. There will be 3 of them. Let's merge the pull request and wait for the build pipeline to complete. We will fast forward this process too. As soon as the build pipeline is complete, navigate back to the deployment and deploy the application again, this time with the values override option enabled. Now that the deploy pipeline is complete, let's check the replica count in the Argo CD application resource. In Argo CD, we can observe 3 replicas being created. To sum up, today we learned what GitOps is and how it makes managing deployments and environments easier. We saw how KubeRocketCI uses GitOps for configuration and automation, and we practiced adding a GitOps repository, configuring a deployment, and overriding values for an environment using GitOps. Thank you for watching. If you have any questions, visit our documentation or reach out to the team. In the next videos, we will go deeper into defining personalized pipelines. That's it. Have a great day.